All right, hello all. So my name is Luke, and I will be giving a quick run through of this 2009 BGCSE exam. Been a while. Uh, BGCSE. Excuse my mistake. So won't be really following any of the standard uh, uh, exam instructions. So really, we'll just kind of jump right into it and then see how quick we can finish this exam. Really, if you've done this exam before, it might be helpful just to kind of gain the perspective of someone that's kind of been through this process and is kind of thinking about the problems in a more abstract way. So with that, I'll just kind of jump into it and start. So number one says that when 4,140 people attend the concert hall is 90% full. Calculate the maximum number of people needed to fill the hall. Okay, so this is some standard percentage problem where you know that 90% of some value x, so this is when the concert hall is full, is equal to 4140. So in order to set this problem up, you have to solve for x. So you can solve this algebraically in a sense where x is equal to 4140 times 100 divided by 90. And so in the same way I would on an exam, I'm just going to use a calculator in order to compute this. And so the answer for this problem is 4600. So 4,600. Okay, so next one is to simplify 125y to the power of 9, all to the power of 2/3. So the law of exponentials states that xn to the power of m is equal to x to the power of n times m. Similarly, xy to the power of n is equal to xn yn. So you should review these concepts. So essentially, if I apply the same thing here, 125y 9 to the 2/3 is going to be equal to 125 to the power of 2/3 times y. So 9 times 2 is 18, divided by 3 is 6. And so now this part is, for most intents and purposes, complete. We just have to solve the 125. So again, in order to do this, we can do 125 to the power of 2/3. And so when you simplify this, you should get 25. The reason being is that, like, for example, you can use a calculator to find out what 125 square is. So 125 to the power of 2 is equal to 15625. And then if you were to compute the cube root of this, of 15625, so if you do 15625 to the power of 1/3, you should get 25. So I don't think it's expected that you figure that out. So I mean, like, just from computing this in some form. But I would imagine that maybe you can compute the cube root of 125, and then you know that cube root is 5, right? So the cube root of 125 is 5, and then 5 squared is 25. So the answer to this problem is 25y6. All right, so next problem. The triangles LMN and DEF are similar. In LMN, LM is equal to 2.8, MN is equal to 4.2 centimeters, and DEF, DE is 6.3. So for LMN, the area is 6.4 centimeters squared. So they want us to compute EF here. So this thing is EF, and they want us to compute the area of DEF. So there are a few schemes you can probably do for this. So recognize that because these are similar triangles, you can just use the ratio. So basically, to solve this, it's just x over 4.2 is equal to y. Sorry, well, not y, but 6.3 over 2.8. So these ratios are the same. So you can make a ratio that says that 4.2 is to x as 6.3 is to 2.8. You can also make the ratio in this way, but you would end up with the same equation. So if you were to divide here, oh, sorry, I made a slight mistake. This is actually so I'm comparing x, right? So x to 6.3 is as 4.2 is to 2.8. And did I get that? This would cross here, x divided by 4.2, and then 2.8, 6.3. Okay, yeah, I see the problem now. I'm so sorry. So basically, so now you should see that you need to do the ratio correctly. So you compare like sides. So x is to 4.2 as 6.3 is to 2.8. So then this should be what your ratio looks like. So now to solve for x, you just have to say x is equal to 4.2 times 6.3 divided by 2.8. And then you should get an answer of 4.2 times 6.3 divided by 2.8. 9.45. So the answer for this is 9.45. I'm just going to erase this all because I don't really need it for now. So we'll come back to just have this clean palette from that. So the area of DEF. So there are a number of ways you can compute this, but the only thing that you need to know essentially are that these angles are equal. So if I come back to my equation here, in order to find the area of a triangle, you just need half BH. The alternative to this would be you use the 1/2 AB sine C, but you have to know an angle to do this. So the question is, how do you find the angle? So, well, actually, you don't need the angle because if you recall, the area of a triangle is equal to half base height. So then, how do these things vary between these two? Well, the ratio of the height should be consistent, and you know the base for this triangle, so you can kind of compare the areas. So the area for the first triangle is going to be half, and then the base is 4.2, and then you also have some height 1. For triangle 2, it's half, and then we just found this bottom base. It's 9.45 H2. So then, what do you notice? So these areas should be proportional. Therefore, the only thing you have to do is, so we know the area of the small triangle. It's 6.4, right? So since the area for the small triangle is 6.4 cubic meters, we just need to find the height, and then we can use the same ratio that we have essentially. So essentially, 6.45 divided by 0.5, and then divided by 4.2 is 3.07. So height 1 is 3.07. What do we know? We know these ratios are equivalent. So the height here should be the height here with the ratio of these similar triangles. So we already know that the ratio is, it's 1 to 2.25. So height 2 is 3.07 times 2.25, which is 6.91. Therefore, area 2, when you plug and chug, its answer times 9.45 times 0.5. So the area is 32.64 centimeter squared. If you want to confirm this, 32.64 centimeters. You probably want to include your units when you're doing the actual exam. You can back check this because you know that these ratios changed by, these ratios changed by 2.25. So the area of this triangle should be 2.25 times 2.25 increased by factor, and we did confirm that with 6.64. So this is the correct answer. 4. It is found that the average number of daily traffic violations is inversely proportional to the number of police stops on the road. So it's 1 over P. The number of traffic violations is 120, when the number of surveillance stops is 5, related to this 1 over 5. So then calculate the number of violations when the number of surveillance stops is increased to 8. So if you recall, when you're doing inversely proportional, you know that V is equal to K over P. Therefore, we just have to find what P is, like what K is in this case. So we know that V is 125. Sorry, we know that V is 120 in this case, divided by 5. So then that means that K, this means that K is equal to 600. Now what we have to do is apply the same formula, which is V equal to 600 over K, in order to determine. So then we should see that as this thing increases, this should be decreasing. So now calculate the number of violations, the number of surveillance stops is increased to 8. Well, 5 plus 8 is 12. So then the answer is 600 divided by 12. So the answer here is 50. All right, everyone, so we're going to continue with solving this problem. So I'm sorry, my laptop kind of cut out, so I wasn't able to finish this. So let's do problem 5, and since I already have the answers written out for everything, we'll just kind of review them and then I'll continue on. So 5, it says in the diagram below, the figure ABCDE is inscribed in a circle of center O. Diameter AD is produced to F, where CDF is 136, and they provide that on the diagram. So it asks to calculate the magnitude of these 4 angles. So this requires you to have some background knowledge. I spent quite some time trying to refresh myself on triangles and circles and inscribed angles, and remembering the rules of quadrilaterals. So this first one is meant to trick you. You shouldn't spend more than 5 seconds on it, because you recognize that the the angle in a triangle that's formed by a semicircle is 90 degrees. So the answer for AED, where this thing is D, is 90 degrees. Furthermore, when you want to find OCD, there are a few steps. First, you recognize that the summation of angles along a straight line is equal to 180. So to find this inner angle, it's just 180 minus 136, which I've computed here. Therefore, this angle is 44. Another important feature is that this is an isosceles triangle, meaning that these two sides are equal because they're both the radius of the circle. Therefore, this side and this side is different, or it could be the same, but it shouldn't be the same. But these two sides are equivalent. We know that at least. If they were the same, then they'd all have 60-degree angles, which isn't true. So since this is 44, then this angle must also be 44. Therefore, we've solved the problem, which is that these two angles are 44 degrees. So I have that written here. Also, with C, recognize that we want to find DOC. So to find the missing angle, we know that the summation of angles in a triangle equal to 180. So I've kind of already put that solution here. With that said, the answer to this is 92 degrees because x plus 2 times 44 is 180. So to find it, it's just 180 minus 44 minus 44, which should give you 92. Next, we just have to find ABC. I also spent some time trying to figure out what they were referring to with this. But then I realized that these two sides are the same, therefore this means that these two angles must be equal here. That also means that these two angles are equal right here. Therefore, since these two sides are equivalent, this means that those two sides are equivalent, and that means that the angle here is equivalent to the angle here, and the angle here is equivalent to the angle here. Recognize that because all these angles equal to 360, we have a way to solve this problem, because the sum of the interior angles in a quadrilateral is 360. So 88. So we need to find the angle here. So this is 180 minus 92, which is 88. So 88 here is also 88 here. So I'll just write 88. And then that means that, so we have a portion of this solved. So 88 plus 88 is, of course, 176. So we just have to compute what these angles are. And I believe we have an answer to this, because the summation of these should be, so that means that 360 minus 88 times 2 is 184. When you divide 184 by 2, when you divide the entire thing by 2, sorry, taking a little bit of time for me to compute this, you get 92. Therefore, the answer to D is 92. Well, the answer to these two angles are 92, but the answer to this problem is 88. We've already figured it out. So, again, I encourage you to review your internal angle, your interior angles, and the rules for triangles that are in circles. So this problem 6, it shows position vectors OA and OB. So the way vector notation works is that O is the initial point, A is the final point, and then O is the initial point, B is the final point. And so to help illustrate this, I drew arrows. So first it says to write down the column vectors for OA and OB. So OA is from O to A, so it's 5 to the right, so 5 to the right in the positive x direction, and then 4 in the positive y direction. So OA is equal to 5, 4. And then OB is 3 in the positive x direction, and then negative 1 because it's 1 in the negative y direction. Okay. Sorry for all the writing. I had already solved these, so I'm just kind of going through the math on how to solve this. So express AB as a column vector. So AB means that you're starting at A, going to B. So you can connect these. So I did two different methods. The first method was just that because I recognized that to get OA, so to go to OA, you have to do negative OA because it's in the opposite direction, and then positive OB to get AB. So I did this math here, and you can see that it's negative 5, 4, plus 3, negative 1, and then you're adding the x components and the y components. And AB is equal to negative 2, negative 5 here. Similarly, you can just count it, and you should get the same thing. So start at A, so negative 1, negative 2 in this direction, and then 1, 2, 3, 4, 5 down, 2 in the negative x direction, 5 in the negative y direction, negative 2, negative 5. Calculate the magnitude of the norm of AB. So to do that, you already know the components, or rather you know what you have an idea of the size of it. It's just 2, 5. So it's the formula for the norm of AB will just be equal to the square root of the sum of its x and y components squared. Which is the formula I have here. It's 4 squared plus 5 squared, and I can write this a little better actually. This should be, well, I'll leave it as is for now. It's 5 squared equal to square root 16 plus 25, which is equal to square root 41, which is equal to 6.40. And this is the norm. This is the norm, or the length of this thing. So I'll leave that like that. Next, we're required to solve the quadratic equations. X squared minus 9 is equal to 0. Well, x squared is equal to 9, and then when you take the square root of both sides, you recognize that you have two solutions. Crucial to mention. You have two solutions because you take the square root, the x can either be negative 3 or positive 3. So the answer is plus or minus 3, or to kind of satisfy the greater, x is equal to 3, x is equal to negative 3. Next, solve 2x squared plus 13x minus 7 is equal to 0. Recognize that you can do the factorization by multiplying 2, so multiplying a by c. So a is 2, c is negative 7, 2 times negative 7 is 14. Can you get 13 by adding these two different things, or other multiples, or sorry, other factors? The answer is yes, you can, because 14 minus 1 is negative 14. 14 minus 1 is 13. So to then get through this, all you have to do is split this up into negative x and 14. Then you can factorize, and so the common term here is x, and you should be left with 2x minus 1, and then the common term here is 7, so you get plus 7, 2x minus 1. And then 2x minus 1 is one factor, and then x plus 7 is the other, equal to 0, and then you have two roots to the solution. So either one of these could be 0, because remember, 0 times any number is 0. So both of these are solutions to this quadratic equation. So since x plus 2 is equal to 0, and the 2x minus 1 is equal to 0, x can be negative 7, or x can be 1 over 2. And these are the answers to this problem. Negative 7, 1 over 2. All right, problem 8. In the figure below, PS is an arc of circle, radius 5 centimeter, with O as the center of the circle. RO is equal to 8 centimeter, PR is equal to 7 centimeters, and POS is equal to 60 degrees. So, using pi equal to 3.142, calculate the area of the sector OPS. So recognize that a total circle is equal to, a total circle is just one 360 degree, right? So that means that a portion of this circle is 60 of 360. So to find the area, it's just pi r squared times 60 over 30. So I reduced it to 1/6, and then I ended up with pi times 5 to the power of 2, since 5 is the radius. And we know 5 is the radius because they gave it to us, which is the OP length. So OS is also 5 centimeters, but we didn't need to know that. So pi times 5 squared divided by 6 is 13.09 square centimeters. Next, we are required to find the angle of the triangle OPR. So we need to find OPR. How do we do that? Well, we have a few things, but the most powerful tool in our arsenal is that we know the size of an angle that are between two lengths that we know of this triangle. Therefore, we can use the law of sines, which states that the area of a circle is equal to AB sine C. So therefore, this is just equal to 8 times 5 times sine of 60 degrees. We should get 34.64 square centimeters. What's the shaded region PRS? Well, since we know the total area, and since we know the total area of this triangle, and we also know the area of this sector from the circle, it's just the total area minus the sector area. So when you subtract 34.64, when you subtract 13.09 from 34.64, you get 21.55 square centimeters. Okay, cool. We're moving forward. And then also, while I'm in the middle of this, if you guys like this video, please feel free to subscribe, like this video. So given that f of x is equal to 5x minus 7 and g of x is equal to 3 plus x over 2, calculate the value of f3. So f3 is just equal to, well, you just plug 3 into f of x. So 5 times 3 minus 7, 5 times 3 is 15, minus 7 is 8. X, where g of x is equal to 7. So 3 plus 7 is 10, divided by 2 is... Oh, sorry, my bad. Misread it. X, where g of 7 is equal to 7. So 7 is equal to 3 plus x over 2. 7 times 2 is 14. 14 minus 3 should give you 11. And hopefully you can follow this. I'm sorry that I'm not writing it as I go, but I lost my entire video doing this. So I'm just trying to make up for lost time. A simplified expression for g f of x. I think this is not written very well, but basically this is like, it's a compound function where first you need to find the value, first you need to take f of x, and then f of x will become your new x in g of x. So I wrote it as g of f of x. So everywhere where x is, I just put f of x in. So it becomes 3 plus, and then f of x is 5x minus 7 divided by 2. And then to simplify, add negative 7 to 3, it's negative 4, 5x. So it's just minus 4 plus 5x over 2. And I wrote that here, sorry. It's just really messy. Hopefully you can follow and can backtrack if need be. Now we need to find the inverse f of x. We need to find the inverse of f of x. Well, that just means that take your function f of x and then write a y, and then the goal is to switch y with x wherever you see. Switch y with x wherever you see y, switch x with y wherever you see x. And then the goal is just to get back to y. So y is just equal to x plus 7 divided by 5. And I circled that here. Okay, moving forward. A survey was done on and I really like this problem. I think this is, it doesn't, I think it's meant to trick you to make it seem like it's a really set intensive problem, but it really isn't. The goal is just to pay close attention to what the problem's asking for and then work through the algebra. So a survey was done on a group of tourists that had visited at least one of the countries, France, Germany, Holland, F, G, H. In the Venn diagram, which is this thing, the expressions represent the number of tourists in each subset. So all you have to do is carefully follow this and you'll do fine. A says to write down the number of tourists that had visited Holland. So the number of tourists that visited Holland are all of the tourists in this thing, right? So it's just y plus 4 plus 26 minus y. Therefore, the answer is 30, right? Because y plus negative y is 0, and then 4 plus 26 is 30. So the answer is 30. Okay, B. So B says there are 50 tourists interviewed in total. Write down an expression for x in terms of y as simply as possible. So recognize that they told you the total tourists were 50. So basically I wrote down the summation of these subsets. So it's just x minus 3 plus 2 plus 2y plus 5 plus y plus 4 plus 26 minus y. So there are a few, and then of course it's equal to 50. So now what I did was I just put all the numbers on one side and I left the algebraic terms on the other side. So I added 3, subtracted 5, subtracted 4, subtracted 26 on both sides, and then from here I ended up, and then x remains, so there's 2y, and then surprise surprise the y's cancel. So your final function should be x plus 2y is equal to this number, which is 16. So then and then I subtracted both sides by 2y, so then I would end up with 2y on this side. So now I have an expression to solve for x in terms of y. So this is the answer. Sorry, it's not there. I decided to use the space that was available. Again, I'm truly sorry. The number of tourists who had only visited Holland was 6 more than the number who had only visited Germany. Write down an equation in terms of y and solve it. So essentially, they're saying that the number of tourists who had only visited Holland, so 26 plus y, is equal to 6 plus 2y plus 5, right? It's just saying it's 6 more. So add 6 to 2y plus 5, and then you have 26 minus y. Now the goal is to solve for y. So easiest way to do this, I moved y to this side, I moved the numbers to the left side. So add both sides by y, and you get 3y. And then I subtracted both sides by 6 and 5. 6 and 5 is 11. This would give me 15. So now 3y is 15, so y is equal to 5. Last part of this says to calculate the number of tourists who had visited France. So the number of tourists who visited France is x minus 3 plus 2. And we know what y is. Y is 5. So then just plug it back into the expression we got from B. 16 minus 2 times 5, which is 10, is 16 minus 10, which is 6. So then x is equal to 6. So I'm going to write that here. X is equal to 6. So then 6 minus 3 is 3, plus 2 is 5. The number of tourists who had visited France is 5. So then as a exercise, you should try to compute everything else and then confirm that you get back to 50. So even if it is as a practice right now, you would see that. So since y is 5, this thing is 15. So these two summed is 5. This thing is 9. And then this thing is 21. So then 20 plus 21 is 41, plus 9 is 50. You probably shouldn't do this during the exam, but we're just confirming that the summation of these subsets give you 50, which is a number they told you, which is the total number of tourists. Okay, this is the last problem I'm going to do before I switch the video. So back to what I was writing. So in a road safety inspection, it was found that the probability that a car had defective steering is 0.075. Okay, so here I'm going to be finishing this last problem that I had started on before I was able to get to the last few problems, and my laptop cut out, so the video didn't save. So in a road safety inspection, it was found that the probability that a car's defective steering is 0.075. In a sample space of 1,000 cars, calculate the expected number of cars with defective steering. So at this point, it's probability. It's something you should have learned through your math curriculum. So the probability that cars defective screening is 0.075. You just multiply 0.075 with 1,000, and that gives you 75. Okay. It was also found the probability that a car's defective tires is 0.05 and that its defective brakes is 0.85. This information is demonstrated in the partially completed tree diagram below. So this asks you to complete the tree diagram. Well, you only have to fill in 4 spots, and you just have to match the probabilities. So this is fairly straightforward. Since the probability that it has defective tires is 0.05, the probability that it doesn't is 0.95, which is 1 minus 0.05. The probability, so then the probability that it will then have defective steering or not is 0.075 versus 1 minus 0.075, which is 0.925. Similarly, if you then go to dB, you then see that you're just matching what the same things are here. So 0.08 if you have defective braking, 0.92 if you don't have defective braking. So seems like very small probabilities. All I have to do is finish C. Calculate the probability that a car chosen at random has defective brakes only. So how do we get to these 3? This one, and this one, and this one as well. So the goal of a tree diagram is that the probability that something else will happen and something else will happen is the multiples of those probabilities. So now what if you had 3 things? Well, it's the first thing times the second thing times the third thing. Each of those probabilities multiplied by each other. So all we have to do is find the end results for these 3 branches, and then we're done. So this first one, where you have the n dB, it can be dt ds dB. So this one is 0.05 times 0.075 times, okay, oh, sorry, so this is actually only defective brakes. So that means that you follow the route of right here. So it should have no defective tires, no defective steering, no defective brakes, so, or just defective brakes. Since all of these different routes provide some other defect, it will then be this times this times this. So the answer seems to just be 0.07 based on what I have written down. I'll just confirm that real quick. 0.95 times 0.925 times 0.08. Yep, 0.07. This is the only solution you can get. So what if you have 2 defects? Well, we have to find the probabilities that give us 2 defects. So you can do dt ds and db. So this is one route. I'm going to do a squiggly line because that kind of helps us differentiate. You can also do dt. You can also do dt and ds db. This is the other route. You can also do n dt ds db. Or you can, yep, that's pretty much it. So then you can't do this because it only gives you 1, this gives you 2, this gives you 2, and this does not give you 2, so you can't use it actually. That's my bad. So sorry. I'm just gonna delete that real quick because that's an error. Need to reset this computer since it's no longer taking my readings. To erase. Okay, so now we're good. So it should be this one that leads to 2. This one will give you, well, I'm sorry. This is actually fine. It's because this would give you 2. Well, and then this one can only give you 1. This one gives you 2. And then this one gives you, okay, yeah, it's because you have this different starting node. So the solutions we can get, we have dt, ds, and db. So the probability here is it's 0.05 times 0.075 times 0.92, and the probability for this one is 0.00345. Okay, how about this path? Well, again 0.05, but we will go the other way. So now it's 0.925. And then to finish, we'll go up here. So then it's 0.08. And we end up with 0.0037. The last route we can do is ndt ds db. And I've already computed this. It's 0.0057. So now that I have this number, I have this number, and I have this number, I just need to add them. So the ones with 2 defects, and bear with me for a second while I add these numbers, 4, 5, 3, 4, 5, plus 3, 7, 0, plus 5, 7, 0. So the answer for this is 0.0129. 2 defects. So a little bit of work, but if you follow through carefully, you should get it. Now has at least 1 defect. So luckily we've already done some of this work because we know that these 3 routes will give you at least 1 defect. So now we need to finish the other routes that have at least 1 defect. Okay, so we need to fill in the blanks. So dt ds db, this will give you, there's a lot of math there, a lot of tedious work. So 0.05 times 0.075 times 0.08. This has at least 1 defect, so it's 0.0003. Other routes that have at least 1 defect, this bottom route also has at least 1 defect. I think it's already been computed. It's the dt nds ndb. So 0.05, 0.925. I think it's already here. Just making sure. 0.92, 0.0425. And I'm also just differentiating the one I'm calculating for C with these clouds. So next one, 0. So then let's see. This is also a route. This is also a route. I think you end up mostly having to calculate everything except for this last bottom one where nothing applies. So now this one is 0.95. It's a lot of tedious work. Times 0.075 times. So we did the top one. So now we're doing a lower one, which is, sorry, made a mistake in my calculator. It's 0.92, 0.0655. I'll just, again, cloud. And I think that's everything. This is 0.07. So that means that now what I have to do is add them. This will take some time. Excuse me while I do this. So 0.0003 plus 0.00345 plus 0.0037 plus 0.0425 plus 0.0057 plus 0.0655 plus 0.07, and you end up with a probability of 0.19115. Okay, so we finished that one, and then I'll move on to this once I segment these videos together. So, diagram shows the location of airports P, Q, and R. Airport Q is 130 kilometers from airport P on a bearing of 115, as shown here. Airport R is 75 kilometers from airport Q on a bearing of 225. So when they say from Q, this is the point of the angle. So the angle comes from north to the line in which it's connected to R. So this angle is so similarly to what was mentioned here from airport P. So it's now just to compute PQR, meaning find this angle. Luckily, we know that, as you recall, the summations of these two angles, since this is just due to alternate angle, this is equal. So this angle would essentially be equal to this angle. Therefore, this angle is 180 minus 115 here. So 180 minus 115. So 180 minus 100 is 80 minus 15 is 65. Therefore, PQR is 360 minus 225 minus 65. So 360 minus 65 is 295. So this is 70 degrees. Therefore, PQR is 70 degrees. So next we need to find the distance from airport R to airport P. And it says to give your answer in the nearest whole number. This distance. Well, we can actually use a few things for this. Since we know the distances of sides between the angle, we can use the law of sines, and that should be mentioned right here in the beginning. So here, if we want to find the length of one angle, we can just use the sine. We can use the side of those two angles. Since we only have one angle, we can use the law of cosines right here. So a squared is equal to b squared plus c squared minus 2bc cosine of a. So we will implement that here. A squared is equal to b squared plus c squared minus 2bc cosine of the A angle, where this is A, this is B, this is C. It doesn't matter for our purposes. So then A is equal to the square root of 130 squared plus 70 squared minus 2 times 130 times 70 times the cosine of 70 times the cosine of 70 degrees. Since I don't have my calculator, I will leave this as is, and we will continue. So we solved B. Next, we need to find RPQ. So for this one, I'm just going to really set up things since I don't have my calculator on me because it died. So I'll show you essentially what we can do. So next thing we need to find, oops, sorry about that. So the next thing we need to find is RPQ. Well, we could do a few things actually. So we can use a lot of sines, which says that sine of A over A is equal to sine B over B. Therefore, we know this angle, so we know RQP. So we know sine of A. We also know the side since we just found that. And we know all length of side. Since this is 75, so B will be 75. And then we can solve sine B. So I'll show what that algebra looks like. It's just going to be B is equal to sine A times B over sine A times B over A. And then to be mathematically correct, this is the sine inverse. And of course, make sure you're consistent. This should all be in degrees. So again, I won't solve this. This is essentially the setup for this problem. And then finally, you're asked to find the bearing of airport P from airport R, meaning that you're finding this bearing. So you do a rotate in your hair. Luckily, you can now find this angle because it should just be, so if we call this, if we were to call this C, for example, so since we've already used A and we've used B, C is just equal to 180 minus A minus B. So some simple arithmetic there. And the bearing of airport P from R is just 360. So the answer is 360 minus C. And then it would be simple plug and chug. You essentially solved this problem. Right is a simple fraction in its simplest form. So we're doing some algebra here. So refresh if you don't remember. So this first problem, we don't have common denominators, so we need to do, so we need to find the LCM. The LCM for this is 12. So, or you can, use a higher common multiple and then just reduce it once you're done. So this just helps simplify things. So since you have a common LCM of 12, you can then, now you need to multiply both the numerator and the denominator for both equations in order to get the LCM on the bottom. So 3 times x plus 2 is 3x plus 6, and then plus 4x over 12. So now we just have to add these. 3x plus 4x is 7x plus 6 divided by 12. And we found their answer. Right. Okay, next one. So again, we need to do the same thing. The lowest common multiple is y times y minus 3, because you see that you just need to multiply these. So let's do that. So multiply both sides here by y, multiply both sides here by y, multiply both sides here by y minus 3, y minus 3. And so now you should end up with 4y minus 3y minus 9, because I distributed when I multiplied through these brackets, divided by y minus 3. So if I understand correctly, they're looking for some simplification here, so you must do that. So 4y minus 3y, well, conveniently, this is y minus 9 over y minus 3. And recognize that this is as simple as this can get. You can expand if you want to, so then you would get y squared minus 9, but it won't do you any good. This is as simple as this. This is as simple as this will get. So this is the answer. Finally, sorry, I'm doing this all on the same thing. So 8z. So this one's a little more straightforward. The LCM is W4. So we'll get a slightly more complicated. So the LCM is W4. All it needs, sorry, I'm not seeing this correctly. It's actually division, sorry. So kind of weird. We'll do it nevertheless. So this is 8z3 over W2 multiplied by W4 over 20z3. Recognize you do this because with division, you flip the fraction. And then you can multiply that. So that when you flip the fraction, it's the inverse. And then you can multiply this first term with this fraction's inverse, or you can just divide. But of course, all our operations that we know are in division. So this simply, so now we have this. You can cancel this. This becomes 1. This becomes w squared. The z3's cancel, and so you are left with 8w squared over 20. A little more straightforward than expected. You can further reduce these, so these will go into 4, so 2, 5, 2w squared over 5. Okay, so all we need to do now is number 14, and we're done. So the following is an incomplete table of values for the graphs y plus 5 minus 4 over x. So we're going to use some hacks here in order to solve this. We're going to derive the function, and then we'll just fill out a, b, c, d, e. I'm pretty sure we can do these without any graph paper. However, you will want to do this without it, but I'm just going to show you algebraically how to get through all these solutions. So all we need to do is fill in these two values, right? So they're probably going to make it 2 points. That makes sense. So y, so we know that, so they say that the graph is y plus 5 minus 4 over x. Okay, that's kind of a really weird way of writing this. I'm assuming there's an error here because they show two different functions here. I mean, it's kind of stupid. Anyway, it looks like they're doing y plus 5 minus 4x. I mean, this needs inequality, so I'm going to assume that this is actually just equal sign and not a plus. I think they made a typo, because otherwise there's no way you can solve this. So y is equal to 5. So now I can kind of fill this in. So 4 over 0.5 is 8. So 5 minus 8 is negative 3. That's the first value. The next value, 4 over 1.6. What is 1.6? That is 2 over, sorry, a little itchy there. So this is, no, instead of 2, this should be 5 actually. 1, 2, 3. So this is 8/5. 4 times 5 is 2. So 4 times, so then you put 8/5 in, you're then doing 4 divided by 8, which is 0.5 times 5. So 0.5 times 5 is 2.5. 5 minus 2.5 is 2.5. So that's it, we've done that. So we filled in, and then we'll just move on. So using a scale of 2 centimeters to 1 unit for each axis, draw the graph of y equal to 5 minus 4x. You need to be super careful here when you have your graph paper and you need to set up your axes. So make sure, like, the first thing you do is you set up the axes. I'm just going to draw a template axis here. And then where you see your 2 centimeter, you draw your mark for each thing. So then obviously, you can, so then obviously for this problem you want to go from 0 to 7, and you can probably use the whole paper provided for that. And then for y you want to go from negative 5 to 5. So your thing most likely doesn't even include this side, it just has this. And then a hack to do this real quickly is that recognize that 0.4, which would be right about here, correlates to negative 5, and then your last point here is that 6 goes to 4.3. So 6, 4.3, you can draw a line straight through and you should see that the points correspond. And you can add those points in accordingly. This is plotting. I'm certain you guys have done it before, so I won't cover it for too much. I'm more interested in the algebra. So using the same scale and axes, draw the graph of y equal x minus 1. So a few hacks to do this. Since you have a grid from 0 to 7, it probably makes sense to graph this from 0 to 7 using the same x, right? So just find the y that corresponds to those x's. So when x is equal to 0, y in this case is equal to negative 1. And then when x is equal to 7, y is equal to 6. So all you need to do is locate, so then if this is my first line, my second line is going to be 0, negative 1. And then, so 0, negative 1, and then 7, 6. So it might look something like this. Now, these lines probably do intersect, but my drawing's bad, so I'll also show you a hack for how to estimate the two values of x when the curve and the line intersect. All you have to do is, so when these two lines intersect, so when these things intersect, recognize that they will have the same x and y value. So that means all we have to do is find, so that means that we can set the y's equal and then go from there. So x minus 1, and notice that they're saying 2. This indicates that it's going to be a quadratic formula. So x minus 1 is equal to 5 minus 4 over x. So let's do some work here. First, subtract both sides by 5. So we should get x minus 6 is equal to negative 4 over x. Multiply both sides by x, and then this is where the quadratic will come into play. So then you should get x squared minus 6x. And then bring the 4 over, plus 4 is equal to 0. So we solve this, you should be able to. So 1 times 4 is equal to 4. However, this tells you to estimate, and because, so let me just make sure I did my algebra correctly. X minus 1 equal to 5 minus 4 over x. Subtract both sides by 5, you get x minus 6. X minus 6 is equal to negative 4 over x. So this means, so when you put both sides, x squared minus 6x is equal to negative 4. You then recognize that this is a little too complicated for doing simple factors. You have to use the quadratic formula, which is x is equal to negative b plus minus the square root b squared minus 4ac over minus 4ac divided by a. However, recognize that you can't, they already don't want you to, they always want you to say where the lines intersect, and you can just get that from the graph. So, shade the region for which y is less than, is greater than or equal to x minus 1, and y is greater than or equal to 5 minus 4 over x. So, if I understand this correctly, I want you to point out when y, so when y is greater than x minus 1, so when x, so in order to do this, there's an overlap, right? So this is in between some region, probably where they're overlapping. So where your y is greater, so then x minus 1 would be below. So let's say I'm drawing some region A, B. Meaning that wherever you see x minus 1 lower than 5 minus 4 over x, which should be true based on looking at this graph. If you compare 1, 1, for example, for y, x minus 1, when x is 1, y is 0. So in this case, y is greater. So in this region, this should be true. But you can just look at this from the graph and then recognize that if your line 5 minus 4 of x is greater, just shade it. Find every region where this is true, at least according to your plot and the scaling here. All right, and with that, I think we have mostly completed this exam. I might try to do another one in the future, but I'll just kind of give you a sense of how they're probably looking at these exams and how they want you to think about the problems. I'll provide some additional resources specifically for this one, since I know it's kind of a doozy. And yeah, I'll catch you guys in another video. I'll probably just try to do a chemistry. Shout out to the Student Shed for providing these BGCSE examinations. And so yeah, I will probably just try to do like a chemistry or physics one. Try to test myself a little bit. So, but this is actually, very interesting, retesting these concepts. The fundamentals that everyone should know. Functions and probabilities and graphs. So yeah, I'm going to fact check myself and then post it on YouTube. And I will see you guys in an upcoming video. Thanks.